Global warming is no longer a distant theory or a future threat. It's a present-day reality, backed by extensive scientific research and observational data. In this video, we'll look into the key evidence supporting global warming, the immediate and long-term impacts on our environment, and the outlook for the future. Through a review of climate science, we'll examine how rising temperatures, ocean warming, shrinking ice masses, and extreme weather events are transforming life on Earth, both on land and in the oceans. Just a reminder, please hit the like button and subscribe if you enjoyed this video. It's free and helps my channel. Thank you in advance. Now back to the video. At its core, global warming refers to the long-term increase in the Earth's average surface temperature. It's primarily due to the buildup of greenhouse gases, such as carbon dioxide, methane, and nitrous oxide in the atmosphere. Since the late 19th century, the planet's average surface temperature has risen by about 2 degrees Fahrenheit, or 1 degree Celsius. With the majority of this warming occurring in just the past 40 years, and with the last decade being the warmest ever recorded, a future projection indicates that there is an 80% chance that at least one of the years between 2025 and 2029 will surpass 2024 as the warmest year in history. The warming of the Earth's atmosphere is closely tied to oceanic changes. Approximately 90% of the excess heat generated by global warming is absorbed by the world's oceans. Since 1969, the upper 100 meters of ocean water have warmed by 0.67 degrees Fahrenheit, or 0.33 degrees Celsius, contributing to a disturbing trend of more frequent and intense marine heat waves. These temperature shifts are not just numbers on a graph. They're triggering cascading effects that threaten marine ecosystems, fisheries, and the livelihoods of communities that depend on the ocean. Another clear indicator is the accelerated melting of glaciers and ice sheets. Both Greenland and Antarctica are losing ice mass at alarming rates, contributing to rising sea levels around the world. The retreat of glaciers has reached record levels in recent years, with the largest 3-year loss of glacier mass ever recorded. As a result, global sea levels have risen more than 4 inches, or 101 millimeters, since 1992, driven by a combination of melting ice and the thermal expansion of warming seawater. This rise significantly increases the risk of coastal flooding, erosion, and the displacement of millions living in low-lying coastal regions. The warming climate also has profound effects on oceanic and atmospheric systems. Rising seas and stronger storm surges lead to more frequent and destructive coastal flooding. At the same time, global warming is amplifying the water cycle, resulting in extreme weather events. These include longer and more intense heat waves, persistent droughts, heavier and more erratic rainfall, and stronger tropical storms. For example, recent studies have shown that climate change has made certain heat waves at least 2 degrees Celsius hotter and up to 10 times more likely than they would be under natural climate conditions. Importantly, climate change is not felt equally across all regions. Some areas, like the Arctic, are experiencing rapid warming at rates much higher than the global average. Meanwhile, shifts in precipitation patterns are causing some regions to become increasingly arid, while others face heightened flood risks. These regional disparities complicate adaptation efforts and pose serious challenges for water management, agriculture, and public health systems. The impacts of global warming on wildlife are just as concerning, both in the oceans and on land. Marine species are undergoing dramatic shifts in distribution. As waters warm and oxygen levels decline, fish and marine mammals are migrating toward the poles or deeper into the ocean in search of suitable habitats. This large-scale migration is not only destabilizing marine ecosystems, but also disrupting global fisheries, reducing catch sizes, and increasing the extinction risk for certain species. Marine invertebrates, such as mollusks, corals, and sea stars, are especially vulnerable due to their sensitivity to temperature and pH changes. Many are stationary or slow-moving, leaving them unable to escape deteriorating conditions. Acidifying oceans dissolve their shells and slow their growth, threatening their survival. If current warming trends continue, scientists predict a 17% decline in total marine biomass by the year 2100. Larger species and those higher up the food chain will be hardest hit, while smaller organisms like bacteria and plankton may fare slightly better. But even plankton, which form the foundation of the marine food web, are showing signs of stress due to rising temperatures and decreasing oxygen. Their decline would reverberate through the entire ocean ecosystem, affecting everything from commercial fisheries to whale populations. Extreme marine events are becoming more frequent and more devastating. Heat waves in the ocean, expanding dead zones, and severe coral bleaching episodes have already caused mass die-offs and are inflicting long-lasting damage on ecosystems. Biodiversity is suffering across the board, particularly in tropical regions where species are less able to adapt to rapid environmental changes. The continued loss of marine biodiversity also threatens the vital ecosystem services oceans provide, such as oxygen production, carbon storage, and food security. On land, wildlife is facing similarly severe challenges. While iconic species like polar bears and penguins often receive the most attention, smaller creatures such as bees, spiders, and other invertebrates are bearing the brunt of the climate crisis. These species play crucial roles in maintaining ecosystem health through pollination, decomposition, and pest control. As their populations decline, entire ecosystems become more fragile and less resilient to further disturbances. Rising temperatures are also forcing terrestrial animals to shift their ranges. Many are moving to higher elevations or latitudes to escape the heat, but not all can relocate quickly enough or find suitable new habitats. This mismatch increases their risk of extinction. In some cases, foundational species are being lost, leading to the collapse of food webs and reducing the overall stability of ecosystems. The result is a growing ecological imbalance that affects both wildlife and the human systems that rely on nature for food, clean air, and water. Looking ahead, the short-term outlook for global temperatures is sobering. There is a 70% probability that the average global temperature for the 2025-2029 period will exceed 1.5 degrees Celsius above pre-industrial levels, at least temporarily. This threshold is widely regarded as a critical limit for avoiding the worst impacts of climate change, although the long-term average may still hover just below it for the time being. The long-term future, however, depends largely on how aggressively we reduce greenhouse gas emissions. If current emissions trends continue unchecked, we could see a rise in global temperatures of up to 5 degrees Fahrenheit, or 2.8 degrees Celsius, or more by the year 2100. Such an increase would bring with it catastrophic effects: more frequent natural disasters, large-scale disruptions to food and water supplies, economic instability, and mass displacement of people. On the other hand, if these emissions peak by the mid-century and begin to decline thereafter, warming may be limited to a range of about 2.4 to 5.9 degrees Fahrenheit, or 1.3 to 3.3 degrees Celsius, higher than early 20th century levels. While still dangerous, this would offer a better chance of maintaining functioning ecosystems and societies. It is also crucial to recognize that some changes are now irreversible on human timescales. Sea level rise and the loss of polar ice sheets will continue for centuries, even if emissions were to stop immediately. The oceans and climate systems have built-in inertia that causes them to respond slowly to changes. This means that even with urgent action today, it will take decades or even centuries for Earth's climate to stabilize. In summary, global warming is real. Much of it is driven by human activity, and it is already reshaping our world in profound and lasting ways. The science has been clear that the future will be increasingly defined by our response to this crisis. Some consequences are already locked in, but many of the most severe outcomes can still be prevented or reduced if immediate and sustained action is taken. Whether through policy changes, technological innovation, or societal shifts in energy use and consumption, our collective choices over the next few decades will determine the health of the planet for generations to come. Before you go, check out some of my other videos. Don't forget to hit that like button and subscribe. Thanks for watching. We'll see you at the next one.